When it comes to define sine or cosine function, there are several ways to do that. So here I will show two ways how this basic trigonometry formula is derived. First, geometrically speaking, consider a circle of radius r and P be any point on the circle. Now if I draw a perpendicular line from P on x-axis, it forms a right angle triangle, and the ratio y by r is our sine theta and x by r is cos theta. We knew this from our school. But what if we take r equal to 1? Then sine theta becomes y and cos theta x. So now the coordinate of P is cos theta comma sine theta. And as P lies on the circle x square plus y square equal to 1, so the point P satisfies this equation, and that's how we have our first formula here. With it in mind, this formula are derived afterwards. Now if you are in college, then you probably saw this equation. It is known as Euler's equation, named after great mathematician Leonhard Euler. Let's take a look how this equation had been derived. For that we have to know the Taylor series expansion of e to the power x, sin x and cosine x. Here is the expansion of e to the x. Now let's replace x by I theta. Here I is our imaginary number. So if we break the parenthesis, we get this expression. Now separate the terms which contains I. Then we are left with this. Now the series within the first parenthesis is nothing but the expansion of cos theta, and the next series is expansion of sin theta. Now let's take reciprocal of this equation. By the way, this follows from the de Moivre's theorem. Now multiply these two equations. We get our first basic trigonometry formula analytically. Now e to the I theta is actually a complex number. Then by the property of complex number, reciprocal of complex number is same as its conjugate. So e to the I minus theta equal with conjugate of e to the power I theta. This implies cos of minus theta plus I sin of minus theta equal to
cos theta
minus I sin theta. Now comparing the real part, we have cos of minus theta equal to cos theta, and comparing the imaginary part, we have sin of minus theta equal to sin minus sin theta. So that's how we get second result. Now here I just replace theta by x from Euler equation. Now differentiate both sides with respect to x. Yet we don't know the answer of ddx of cos x or sin x. So just leave it as it is for the time being. We do know the derivative of e to the power ix, which is I e to the power ix. Now replace e to the power ix with its value here and multiply the I. Now compare the real and imaginary part from these two equations. Finally, we get the derivatives of sine and cosine functions.